Hello guys, welcome back to John's Workshop, and in this video we're going to continue with the fitting of the DRO to the milling machine. We've done the Z-axis already, and the next one we're going to do will be the X-axis, and I'm choosing that one because it's probably the next easiest out of all three. So I've watched various other people do similar things on their own machines, and I've got two choices with the X-axis. I can either fit it to the front of the machine or the rear of the machine, and they're the two choices. Most people fit the DRO to the rear of the machine so it's out the way, and I've seen a couple of people that have fitted it to the front of the table, and I've been giving that some real thought, and there's some pros and cons associated with both really. So if I fit it to the rear of the machine, effectively this distance here, which is about between 30 and 40 millimeters, I've not measured it, but I will lose that amount of y-axis travel, and I've only got 200 millimeters of travel in total, so that's quite a significant proportion of loss. And you actually lose more than that, because this rubber matting that's behind here that guards the bedways sort of curls up and would get trapped behind here, so you end up, I'm going to lose 40 millimeters of travel, which is a lot from 200 millimeters. So the pros of putting it at the front are sort of many. If you think about the swarf, when I'm milling, when I'm side milling, I always work on the right hand side of the vise so that the swarf is being directed towards the back of the machine. If you're using any sort of coolant or cutting oil, if the swarf's going that way, the cutting oil is also going that way. So it's the most aggressive environment, if you like, for the scale to be sat in. If you put it on the front of the machine, it's far less aggressive, it's cleaner, it's easier to access to fit, it's easier to access to maintain. It's just generally going to be a much easier fit to put on the front. It will need some modification. I can't put it directly on the front of the table, and I'll bring you in and show you why in a moment. So the choices I've made are to stick it at the front. The only sort of disadvantages of putting it at the front are when you're loading heavy things like rotary table or vise. If you're not careful, you could actually clout the scale as you're putting heavy things onto the table. But that's really the only disadvantage with putting it at the front, other than I need to do some work with the axis locks and things like that, and I'll bring you in a bit closer and show you that just now. So if I look at a fit on the back of the table, what I would have to do as well is reposition this rubber seal that guards the y-axis, because I would need to remove that to put the reader head on the table and somehow try and reconfigure this so that it fits back over the top of the reader and protects the reader unit, and that's quite a bit of work. The access isn't brilliant because you're trying to work down behind the table, and as I've said, I lose that much y-axis, which I'm not really prepared to do on this machine. So that's the sort of back view, and I'll bring you around the front now and we'll discuss the modifications that I need to make to fit at the front. So if we look at the front of the table, the things I need to bear in mind are, I don't really want to remove, I've got two axis end stops, one at each end of the axis, and there's a steel plate in the middle here that they work up against, and that's to stop you over travelling the end points of the axis, and they're currently set to almost the maximum travel of the table. So that's one thing I want to try and avoid, interrupting or disturbing that, which means I can't fit the scale directly onto the front of the table, which would obviously be the easiest fit. Also, there's these axis locks. Now these aren't the originals, I've put these on, and I made a bit of a mistake when I put these on. I don't like them, they're horrible. I've bent this one several times, you can see it's all wibbly wobbly, that's another good engineering term. And the reason that's gone like that is because while I've been watching what's going on up here, and I've been traversing in the y-axis, you can see what's going to happen at that point. That handle, if it's in that down position, gets caught on the front of there, so I just really don't like them. They're not right for this machine. So I wanted to do something with these anyway, so these are going to get replaced with something else. So they'll need to come off, and the plan is, and if you imagine this has got the scale inside it, this is just the cover plate for now. So this is going to sit somewhere outboard of the table surface, and what I'm going to need to do that is make a couple of spacers that fit into this T-slot. So I'm going to need to make a couple of small T-nuts to go in the T-slot, a couple of turned spacers that have turned parallel to stand off, and then I'm going to put an aluminium backing plate that I'll make up myself, strung between the two spacers that I've made. And I think there's just about room in the centre of the table to make a support bracket to go behind that aluminium as well, so that it's supported in 3 places, and then the scale will fit to the front of that aluminium backing plate. I'll drill it so that this scale cover also fits onto the backing plate, and then I need to work out how I'm going to attach my reader head then from down here somewhere up, using a bridge again out and up underneath into the reader head. So that's the plan. So I'm going to start off with measuring up these T-slots. We're going to make a couple of quick T-nuts up to fit in these T-slots, and then we'll crack on with the rest of the fit. Right then guys, I've got a piece of mild steel in the vise, and we're just going to block this up to the rough sizes, or certainly one of the rough sizes I need for the T-slots. So I've got a 20mm diameter solid carbide end mill in the collet chuck, so we're just going to take a couple of cuts off this, take a measure, and then finish that to size. Right, we're on the second dimension now, so we've got this is 20mm, we've machined that to thickness. We're just going to machine down just a portion of this piece of stock, as much as I need to make 2 T-nuts, so I'm just going to machine that down to size now. So next job, guys, I've got a 6mm end mill, and we're just going to put some relief for the T-slots. So I've got two here, so I'm going to do half of one side, pitch across, do a centre slot that will create the second step on the first one and the first step on the second one. That's confusing, but it will hopefully become clear as I go. And then pitch across the third time to do the far side. So we'll just see how that goes. Right then, guys, there we go. There's two T-nuts. So next job is load the chuck back in and drill and tap the two holes in the middle. Then the final job then is to get on the saw, split two saw cuts, and then all I've got is one face to clean up, and that's those two T-nuts made. So I'll get reset back up with the chuck in for putting the two M8 holes in the middle. Final note, some of you may ask why I've done it that way round and not machined into the long length of it and split it lengthways. Tighter than 2 coats of paint, and this is the least minimum use of material, so that I keep the maximum amount of material left for another job at some point in the future. So the next job on these now is to set up with the edge finder and then put two M8 holes, one in each T-nut. So we'll just get on with that now. There we go. That's got both of those drilled and tapped. Next job now is to get these split off the block on the bandsaw. I'll probably show a little bit of that, and then we'll bring it back to the mill and finish the final widths off for the bottom of the T-nut. What I've done, I've finished these two T-nuts off to size on the width. Apologies I didn't film that, it was just literally just cleaning one edge up on one and both edges on the other. So they're finished width now, that's fine. They won't fit in the T-slot because the T-slot's a bit of a funny shape on the front of the mill. And I've taken the T-nuts that are in the back of the axis stops that came with the mill out, and they've got big chamfers on the back so that they fit into the T-slot. So I've got a chamfer mill in there now, and we're just going to gently pop 45 degrees chamfer on the edge of both of these. So I'll show you some of that. I got away with that. That one's just about to exit the vise. I was really lucky there. I think I'll finish those off one by one. I pitched them each end of the vise to hopefully stop that happening, but it looks like I've just got away with that. That was on its way out. We'll take that one as a getaway, get out of jail free card, I think. I'll just set that back up and we'll finish them off separately. There we go guys, that's got those finished. It's quite a bit of work really for two little T-nuts, but anyway, that's them done with the chamfers on the back, and I've test fitted them in the T-slot and they fit fine. So I'm just going to give them a quick degrease and then we'll chuck them in the chemical black just for corrosion protection, and that's that part of the job done. And the next part, we're going to move on to the lathe and we're going to make the two spacers to space the aluminium piece away from the table. So we'll bring you back at the lathe when we're doing that. Hello guys, welcome back to John's workshop, and in this video we're going to continue with the fitting of the DRO.